All right, here's our video today. Pedigree collapse and shared ancestors. How we are all related, and we are. We are all related, and I'll talk about that in the video. So pedigree, that's that word. Let's get our pen ready here. Pedigree is a record of your descent, your lineage, right? Your ancestry. Let's write that down. So put a little arrow here. The record of you, the record of descent. Or let's say ancestry. See if we fit it in there. A little blurry. Let's change the color. There we go. Ancestry, your lineage. So we can look at the record from you or me or Aunt Sally or anyone on planet Earth at any time, right? So when we do that, we will notice, if we just keep going in the generations, we will notice something strange. And we'll talk about that. So and you can see in the background this pedigree chart. Well, I'll explain. So let's get a clean page. All right, so what should we use? Use yellow. So let's say over here we had a person, right? Any person on Earth. And since I made a circle, it'll be female, because in pedigree charts, the circles are females and the squares are males. So let's just call this person, what shall we call this person? Who knows? Call her Tina. There's Tina. And of course, Tina will have a mother and a father. And of course, we're just talking biological here. And then we can just keep going, right? And so let's just make another one. And of course, if you keep going, this gets could be very crowded. So you have to write it, you got to make it small. So this will be her parents. We'll just say her P for parents, and this is her grandparents. And again, the circles are females. And we can keep going. And you can see as if you keep going, you'll have more and more and more ancestors. And let's see if we can fit another one in here. So we'll put one over here. So this would be your great grandparents, or Tina's. And we'll fill it in. You can see how it's already getting muddled. It's hard to fill all this in. So if we look at the chart, you have 2 parents, 4 grandparents, 8 great-grandparents, and it keeps going and going, and it doubles each time. And the formula actually is 2 to the nth to find the next generation. And wherever you start your pedigree chart, the last one you do will be the first generation. So in this case, her great-grandparents will be the first generation, and her grandparents will be the second. Her parents would be the third generation, and she would be the fourth. And they're written in Roman numerals. When you look at a pedigree chart, they are written in Roman numerals. And again, the circles represent what? The females. Excellent. You can imagine if we included her mother's sisters, if her mother had sisters or brothers and their children, how the size of it, how it would grow exponentially also. Now, from Tina, if we go up, the first generation away from Tina are her parents. But again, on the chart, the whatever you listed first, as far as like the great grandparents or whatever, that would be the first generation. So in this case, that's the first generation, even though we know there's another generation older. And if we put some numbers in, so let's just put numbers here. I'll show a chart later. So 2 parents, 4 grandparents, 8 great-grandparents, and then, of course, it just keeps going up, 16, 32, and so forth. And you have to think about this. If we look at these 32, right, so this would be, the 8 is the great-grandparents, and this would be great-great-grandparents, and this is 32 great-great-great-grandparents. All these people had to meet, or you wouldn't exist. That's pretty strange, right? But that's not really the strange thing I was talking about in the beginning of the video. We'll talk about that in a minute. Let's look at what 7 generations would be. Now, in our model, we'll assume that each generation is 25 years. If we look at that, let's look at the chart. So with 7 generations, that's 128 descendants. 128. And of course, the other chart shows the amount of DNA you would share, which is when you get to the 7th generation, it's very small, the amount. So if we take our model, again, we're saying 25 years for each generation, then in 1,000 years, guess how many descendants you would have if we look at that chart of 25 years each generation? In 40 generations, you would have 1 trillion ancestors. Now, here's the strange part, because if we look at 40 generations, the estimated population at that time would have been about 300 million. 40 generations is 1,000 years based on this model. So the population, let's write that down. The population 1,000 years ago, by the way, look at this tree. What would happen if we keep going in the chart? Let's get the pen going here with red. So 1,000 years ago, 40 generations. We're talking what you had to have would be 1 trillion ancestors. And of course, you didn't have 1 trillion, even though the math says that. That's the strange part. Because remember, there was only 300 million people living 1,000 years ago. There's 8 billion today, so we're not even close to that then. So if you look at that percentage, if you're looking at 1 trillion, but yet there was only 300 million people, that percentage is 0.03%. It's not even 1%. And you think of today we have over 8 billion people, but 8 billion people, well, that's still less than 1%. It's only 0.8% of the population of the assumed ancestors. So this is where pedigree collapse comes in. The title pedigree collapse, or they also call it ancestral convergence. Since you had to have 1 trillion ancestors and it's impossible for you to have that, the only answer would be pedigree collapse, and that's inbreeding, where cousins are marrying cousins and so forth. Let's talk about that. Now, here's a very simplified chart. Of course, there'd be more people depending on the person involved in this. Let's make sure my pen's working. So here you are, or someone who had a son or a daughter, and perhaps this person that I just circled is a grandma or a grandpa. So again, you have 2 parents and 4 grandparents, and you have 8 great-grandparents, 16 great-great-grandparents. So from your grandfather, you can look, these are your cousins, your first cousins. And you can see right over here that your first cousins normally share about 12.5% of your DNA. The chance of mutations and genetic defects is high at 12.5%. But we know in the past, there's been a lot of occurrences where people married their first cousin. And there's a lot of occurrence where you see these mutations, these genetic deficiencies where people are born with. Now, if you share a great-grandfather, well, then that would be your second cousins. And as you go down with each cousin, you can see that the shared percentages go down. So with your second cousin, you're sharing about 3% of your DNA. So the chances of genetic defects will go down, but it's still there. It's not high, but it is there. But when you get to your third cousin, just think about it. Your third cousin, you don't even have a 1% of your DNA. So the chances of genetic defects are smaller. But imagine your fourth cousin. With your fourth cousin, you probably have, if we look at this model that we've been doing, where every 25 years is another generation, you would probably have, if we assume that everyone just had 2 children, you could have 512 fourth cousins. And how many of you out there know your fourth cousins? Not many people know their fourth cousins. Now, the chance of genetic deficiencies or disorders from a fourth cousin is really low. And you can see through the history and looking at our estimated population of 1 trillion, marriage between first cousins probably happens, especially in a lot of isolated, I should say fourth cousins, are probably happening in where people wouldn't even know. You can see how this chart gets blurry, right? Fourth cousins, fifth cousins, sixth cousins. You might have 1,000 fifth cousins. How many do you know? How many sixth cousins do you know? How many people in the world know their sixth cousins? You probably don't. And if you think about how many, let's get my pen going here. Let's write it all down. So again, let's look at these numbers, right? You have this, we'll just say your parents. You have 2 parents, and you have 4 grandparents. And you probably most people know their grandparents. They probably don't. Maybe they weren't alive when they were, maybe we weren't born when they were alive, but you do know them. But when you get up until the great-grandparents, most people don't know all of them because there's 8. Maybe you know 1. Do you know all 8? Do you know all 16 of your great-great-grandparents? How about the 32 of your great-great-great? The 64, and so on. How many of you know that you're 60? And just think of all the cousins involved in that. So you wouldn't know all of these people, especially as you go back further in time. And if you don't know them, you definitely wouldn't know their children's besides your grandfathers, grandparents. So even though it's strange to think of the population of 1 trillion, and yet there was only 300 million 1,000 years ago, it's not too strange to think that fourth and fifth cousins could have married. And it's still happening today. Again, to clear it up, how many people out there know their 7th cousin? I'm guessing no one knows their 7th cousin, unless you do one of those 23andMe's, maybe you can figure it out. Or 8th cousin, 10th cousin. The numbers keep going up exponentially. So we can see how inbreeding would have happened. Now again, when you get to the 4th cousin, which many of us don't know, the chance of mutations is low. 5th cousins is extremely low. 10th cousins is very extremely low. But like I said in this video, we're all related. If we go back 2,000 years, if you go back 80 generations, that's 2,000 years ago. Guess how many descendants the math would tell you you had? Who wants to guess? This is a big pedigree collapse. We're talking 1 octillion. That's right, 1 octillion. There's a 1. That's 1,000. That's 1,000,000. That's 1,000,000,000. That's 1,000,000,000,000. That's a quadrillion, quintillion, sextillion, septillion, octillion. 2,000 years ago, you would have had to have 1 octillion descendants according to your pedigree chart. But that didn't happen, right? 2,000 years ago, there was probably less than 200 million people living. 2,000 years ago. So everybody on this planet, if you look at the probabilities, everybody on this planet had to have a most recent common ancestor, shared a common ancestor, or more. We probably shared 1,000 or more 2,000 years ago. So we're all related. Imagine going back 3,000 years ago. The number is just beyond octillion. The pyramids were already 1,000 years old 3,000 years ago. Talking about time of Confucius and Homer, who wrote the Iliad, the Odyssey, and King David, and Buddha. That's 3,000 years ago. The number, let's write it down over here. Let's write the number of the descendants your math had to have. 1 times 10 scientific notation to the 63rd power. That's a vigintillion. It's beyond thinking, right? So again, keep going back. How many shared ancestors would we have? I can't even fit in a vigintillion on this paper. All right, so that's our video today.